wondering why I'm starting a science presentation with a picture of Ho Chi Minh? Well, it serves to illustrate a point I'd like to make about the power of received wisdom. You see, a couple of years ago, my history class was studying the Vietnam War when a question arose as to why anyone would want to fight to implement communism. Is it not inherently a bad thing? What makes you think that? Asked my history teacher. The Cold War was the immediate consensus response. But, as my teacher pointed out, we had all been born after the Cold War ended. We had not grown up to fear Eisenhower's falling dominoes. We simply accepted that communism is a bad thing because that was what we had been taught. However, something that my generation most definitely has grown up to fear is a change in climate. Between 1951 and 2010, Earth's average global surface temperature rose about 0.6 degrees Celsius, and the IPCC has concluded that it is extremely likely that human activities caused more than half of that increase. The main mechanism behind the anthropogenic climate change we're currently seeing is the intensification of the greenhouse effect. I'm sure you all have some understanding of how this works, so I'm just going to give a brief introduction. The sun emits radiation, which is absorbed by the Earth and re-emitted by the Earth. However, it's re-emitted in a longer wavelength form, and gases in the atmosphere, such as carbon dioxide, are able to trap most of this radiation and re-emit it back to Earth. Thus, these gases function something like the glass roof of a greenhouse, allowing energy from the sun to enter the Earth system, but preventing much of this energy from leaving the Earth system, and this thus warms the Earth. It makes sense that if we were to increase the concentration of the greenhouse gases in the atmosphere, we would see some warming occurring, and this is what has happened. So prior to the Industrial Revolution, atmospheric carbon dioxide concentrations were about 275 parts per million, and by 1994 they'd reached 358 ppm. And the IPCC has estimated that these increased greenhouse gas concentrations contributed between 0.5 and 1.3 degrees Celsius to that 1951 to 2010 observed warming. Now, climate change is going to have some pretty severe consequences for Earth, and these images just illustrate modelled changes in precipitation, runoff and soil moisture that could occur with this rise in temperature, as well as changes in sea level. However, it's not all bad news. Although the Earth is committed to some degree of climate change, we can limit the extent to which this occurs. So this again shows modelling by the IPCC, and it shows that by the end of the century, the Earth could experience warming of anywhere between 0.3 and 4.8 degrees Celsius, depending on how severely we mitigate our emissions. Thus, it behoves us to do something to reduce our carbon dioxide or greenhouse gas emissions. And in New Zealand, one of the main ways we can do this is by targeting our energy sector, because it's one of our major emitting sectors. In 2012, it was second only to agriculture, and combined the two sectors produced 90% of our carbon emissions. It was also the fastest growing sector between 1990 and 2008. And so when we're thinking about reducing emissions from our energy sector, we're really thinking about reducing our reliance on fossil fuels. However, if that's not enough to convince you of the need to move to a fossil fuel-free future, these graphs might. So this just shows that our fossil fuel supplies are running out. This top graph illustrates that we're currently at the top of this small blip in human history, which is the oil age, and we're about to start falling rapidly down this side of it. And the lower graph illustrates that we've got less than 100 years of oil left on Earth, and barring substantial new resource findings, less than 100 years of coal and gas as well. Now, when we think of reducing reliance on fossil fuels in the energy sector, we tend to immediately think of renewable energy. And in the New Zealand context, this is a very viable solution, because already just 28% of our energy generation comes from fossil fuel sources. However, there are a couple of problems with renewable energy sources, which suggest that moving into the future, we won't be able to rely solely on these resources. Firstly, there's a problem with supply. So obviously, if we were to get rid of fossil fuel energy generation, we'd have a nearly 30% shortfall to make up. And it's difficult to see how renewable energy sources could make up all of this shortfall. So currently, most of our energy generation comes from hydroelectric power, but there's not a lot of capacity for expansion of that. So there's only a limited number of rivers we can dam, and in fact concerns arose as early as the late 1960s about where future hydro production in New Zealand could be situated. And it's also difficult to see how technologies such as solar or wind could make up that shortfall because, as Max has already mentioned, they require a very large land area. There's another supply problem with renewable energy sources, which is sort of a peculiarity of New Zealand's geography. So currently, with our reliance on hydroelectricity, most of our generation happens at the bottom of the South Island. But our main use of energy occurs in the North Island, and particularly around Auckland. And this is very inefficient because energy has to be transferred long distances. So ideally, we could actually situate our future power supply close to our major use areas in Auckland. There are also problems with the reliability of renewable energy sources. So obviously the sun doesn't always shine, and even in Wellington the wind doesn't always blow. And we can't currently store energy produced by these means for times when production from those sources is reduced. There's similar problems with hydropower. So this relies on sufficient runoff production to rivers. And in 2012, our emissions from our energy sector went up 2.9% due to reduced runoff production. And finally, it's important to keep in mind that all technologies have environmental effects. No technology is 100% sustainable. We perhaps see this most clearly in cartoons such as this one, which illustrate the concerns about the potential pollutants which might go into producing biofuels. But it's also illustrated by things such as the fact that today's most sustainable solar panels rely on very rare elements such as indium, which we maybe have just 10 years of left on Earth, and also by this modelling. So this is modelling by scientists at the Max Planck Institute, and they have suggested that large-scale conversion to wind extraction could actually cause climate change as significant as doubling CO2 levels to 720 parts per million. So they modelled it in these 4 climate parameters, and at the most extreme end of wind production, the change was similar to that caused by a doubling of CO2 levels to 720 ppm. And that's because extraction of wind power changes global atmospheric circulation patterns. So none of this is to say that we shouldn't use renewable energy. It will certainly be an integral part of a fossil fuel-free future. However, it does suggest that the most sustainable option is not going to be the one which puts all our eggs in one basket. Instead, we need to develop a variety of resources. That way we're less likely to overexploit any single resource and more able to adapt to changes in the availability of those resources which do occur. And so it's in this context that I'd like to suggest that New Zealand consider adopting nuclear power. Now, before you shoot me for being anti-Kiwi, let me explain. Obviously, New Zealand has a long and proud history of being nuclear free. But whilst this was probably an appropriate response when it developed in the 70s and 80s, the international situation has changed and so has the technology. And thus it's really important that we actually reconsider this position. So one of the major advances in nuclear power has been that we are coming close to being able to do something called fusion on Earth. So there are 2 nuclear processes, and today when we're talking about nuclear power, we're talking about nuclear fission, the splitting of a radioactive nucleus into 2 smaller nuclei with the release of energy. Fusion is the opposite, fusing 2 smaller nuclei into a heavier nucleus, again with the release of energy. A fusion reactor would have significant advantages over fossil fuels, over nuclear fission, and also over renewable energy sources. So the fuels for an on-Earth fusion reactor are abundant. We would fuse the heavy isotopes of hydrogen, deuterium, and tritium. There are 60 million years of deuterium left in the sea, and we can make tritium from lithium according to this reaction, and we've got at least 30 million years of lithium left in the ocean. A fusion reactor also produces very little radioactive waste. So the main byproduct of the reaction are these stable helium atoms. Radioactive waste only results when these escaping neutrons collide with the reactor wall. And in the New Zealand context, fusion power could make up some of those shortfalls in renewable energy production that I discussed earlier. So it could make up that shortfall that would result from the removal of fossil fuels from our energy supply. It could also be situated close to our major use areas. So nuclear power was actually suggested for New Zealand in the late 1960s, and a site at Oyster Point on the Kaipara Harbour was suggested. Obviously, there is a fairly major barrier to New Zealand adopting nuclear power, and that is societal attitudes. And this goes back to what I was saying at the beginning about the power of received wisdom. We are brought up in this country to believe that nuclear power is a bad thing. However, as this quote illustrates, we live in a world of increasingly changing science and technology. And thus it's actually really important that we're willing to reconsider our positions on different different technologies. The rest of the world is going to, and if we want to keep up with them, we need to be willing to at least reconsider our position. And if we do choose to continue to be nuclear free, to make sure that that decision is based on a strong scientific basis. And so that's why we need to start talking about nuclear power as a country, because there is going to come a day in the future when New Zealand needs to think seriously about how it plans to power itself moving into the future. When that day comes, we need to be able to have a full and frank discussion about all the options available to us, including nuclear power. At the moment, such a discussion would be impossible to have because of our attitudes towards nuclear power. And it's for this reason that New Zealand needs to talk about nuclear power, because attitudes take a very long time to change. Thank you.
Thanks, Rachel. As far as I know, even the most avid supporters of nuclear power say that New Zealand's way too small and couldn't even begin to afford it.
Yes, so this is another problem, but it's not an insurmountable problem. So basically what that problem is to do with the size of New Zealand. So we currently produce about 9 gigawatts of power. A typical nuclear reactor, and this is talking about fission because obviously we don't have fusion reactors yet, is about 1.2 gigawatts. And so whilst it seems like, maybe a good idea if we could produce so much energy from one point source, it's actually a problem because if that reactor goes offline, then where do you make up the shortfall? But it's not an insurmountable problem. So in the fission field, they've actually developed some micro nuclear reactors. So these aren't on the market yet, but they're in development. There's one being developed in Russia, which is 35 megawatts, and Toshiba has developed some which are 50 megawatts. And so those could potentially reduce those problems to do those size problems because they're much smaller. And obviously it would require significant development, but just because something's not possible now is no reason not to invest in it. And perhaps that's something that particularly New Zealand problem that New Zealand scientists could apply themselves to, and then that would obviously have economic benefits too in terms of being able to export that technology to
You don't think you might have given up a little too easily on renewable energy? I mean, the issue with renewable energy is storage. You could be working on better storage of that energy. We wouldn't need to go nuclear.
Well, I mean, I think that goes back to what I was saying about not putting all your eggs in one basket. So I think definitely we should work on renewable power, but there are storage problems, obviously, and like I was saying, there are those problems too with sustainability, with potential environmental effects. And so if you can actually diversify and be based on a broad range of things, then that maybe helps to ameliorate some of those potential issues. So, I mean, I guess really the reason we're in the situation we are today is because we have really overexploited a single resource, the fossil fuels. And potentially if we had diversified earlier, we wouldn't have this problem now.
Peak oil, your peak oil was very peaky.
Yeah.
And a lot of people have disputed that, and they've said, look, we'll keep on finding more oil and we find more ways to extract it from places we never even knew. You're not convinced?
I'm not convinced, no.
So are we in peak oil? Have we had peak oil, or are we coming? I think it depends on the country too, like in terms of, like New Zealand's probably had its peak oil because we don't have a lot of oil anyway. Some nations, maybe there's still a bit to find, but I don't think there's a lot. And I think also you have to think of the environmental effects of extracting that very difficult to get to oil as well. Is it actually worth it? If it's very difficult to extract and if we know it's going to contribute to climate change, then even if it is there, should we be using it?
Thank you, Rachel.